It comes to a point. Think about it. It says y is always the absolute value of x. So if you put 5 in for x, you would get 5 in for y. 1 and 1, 2 and 2, 3 and 3, right? So part of it does look like y equals x, that part right there. If you put negative 1 in for x, y would be 1. If you put negative 5 in for x, y would be 5 because it has to be the absolute value of it. So it's all in 1 and 2, the two quadrants where y is always positive, which is what absolute value is mostly about. What was my next one? Square root. Y equals the square root of x. Y equals square root of x. Let's zoom in once. This is y equals the square root of x. Notice there's no negative x's there. The negative side is empty. It's a ghost town. Can't take square root of a negative number. That would just be silly. So square root of negative x. And the square would be y equals x squared, of course, and the cube would be y equals x cubed. X squared we pretty much just did, but this we'll look at it again. There is y equals x squared. It is the parabola, the bowl. And y equals x cubed is that's that funky thing that does a little S curve as it comes through the origin. It rises to the right and it falls to the left, sort of thing. And from those 6 basic functions, we're going to do a lot of stuff, because most graphs that you see are some variation of one of those basic functions. They have just been moved or stretched or shrunk. So let's look at some translations. This is where it gets exciting. Are you excited, Courtney? Thanks for your honesty. How to translate means to move things around. How do you move things around? Well, here's a few ways to do it. Let's say we have a function, f of x, and we want to create a new function that is a translation of f of x. And this is how it happens. Here is a vertical shift c units up. You take that f of x and you add c to that. I think y'all already knew that one, or maybe figured that one out. A vertical shift c units down. You take that f of x and you subtract c from it. Horizontal shift c units to the right. You take that function and instead of x, it's going to be x minus c. Likewise, shift to the left, f of x plus c. So let's take something simple. Let's let f of x be x squared. That's a nice easy one, right? And let's move it around. That confused Carrie in second period because she thought we'd have to move it twice. I was like, Carrie, it's a song. Yes. So, oh, I love that song. So let's move it, move it. Let's move it everywhere. Let's take it up. Oh, let's take it up 5 units. Well, a vertical shift up says that you take your function, you add however many units you want to move it up. So this is going to be, we're going to take that function and we're going to add 5 units to move it up. So what we're going to graph is x squared plus 5. Let's let this be x squared, and I'm going to come down here and do our translation. So here is x squared plus 5. And let's graph. And I'm going to have to standard zoom because it's not even on the screen. There we go. Okay, so there's x squared, and there's x squared plus 5. We moved it up 5. Let's move it down 5. That is going to be f of x minus 5. So let's graph that, and all I have to do is change that plus to a minus, and that would give me x squared minus 5. And there's x squared, and there it is, having been moved down 5. It looks like an evil smile, kind of. Let's move it to the right. How many, Amelia?
8.
Wrong. No, I'm just kidding. Yeah, we'll move it 8 to the right. So that means, this is the weird one. This new function is, we're supposed to take f of x minus 8 to move it to the right. Well, f of x is x squared. So instead of x squared, move down one more line, we are going to have x minus 8 squared. Okay, so it said horizontal shift c units to the right, take f of x minus c. So that's what I did. So I'm going to have to wipe this one out, because this is now x minus 8 squared. There's x squared. And there's x minus 8 squared. It's been moved to the right 8 units. Let's move her to the left 8 units. It's going to be x plus 8 quantity squared. So let's see. Let's say all I have to do is change that to a plus. And it has been moved. There's x squared, and there is x plus 8, the quantity squared. So it's kind of easy to move those things around, right? Do you find ease and relaxation in this, Frady? Totally? Cool. Well, let me ask you this then. What if I made a function that was x minus 5, the quantity squared, plus 3? What would that look like? Exactly. Which way are we moving it? We moved it to the right 5 and then up 3. And it's squared. So it looks like your basic x squared. Think of that little bowl. But it's been moved to the right 5 and then up 3. Hey, let's try it just for fun. This is x minus 5 squared plus 3. So there's your basic x squared. And there it is, moved over 5 and pushed up 3. Oh, the things we can do. So I can give you a function, x cubed, something, and I can tell you I can ask you, what is the equation if it were moved up 3 and down 4? Moved up 3 and to the right 4. And you could easily write the equation of that function.